Hello, in this video I'll briefly walk through my project on emotion detection for Bengali and Banglish text. The goal of this project is to detect 6 emotion: anger, disgust, fear, joy, sadness, and the surprise from short Bengali and Banglish sentences. This is useful because most existing emotion models focus on only English, while people in Bangladesh often uh, write in mixed Bengali script and Banglish. Here you can see I start by importing the main libraries, typically NumPy and Pandas for data handling, Matplotlib for visualization, and TensorFlow for building the neural network. In the next cell, I load the Bengali and Banglish 80K dataset. It contains around 80,000 sentences. Each label with one of the 6 emotion. I quickly check the height of the data frame and the label distribution to see how balanced the data is. The next I'm doing the pre-processing. In this session I clear the raw text. I remove URLs, methods, hashtags, extra symbols, and extra space. I also drop duplicate or nearby empty rows, and hand map each emotion labels to a numeric ID. After that, I split the data terms validation and test set. This ensure I can turn the model on the validation set, then evaluate value on the unseen test set. Here I built a tokenizer on the training test, limiting the vocabulary to the most frequent words. Each content is converted into a sequence of integer IDs and padded or truncated through a fixed length. So many input has the same space. This NumPy array This number area are what I fed into the neural networks. Here, in this part, I define the 2 models, an LSTM and bidirectional LSTM. Both start with an embedding layer, then an LSTM layer followed by a dense layer with shallow dropout, and finally a softmax layer that output probabilities for these 6 emotions. I compiled the model with a switchable optimizer and loss, and then trained them using the training, switchable, monitoring, validation, and accuracy. Here I evaluate the models on the test set and print metrics like accuracy and macro FISCR. The key result that the tuned bidirectional LSTM perform the best, achieving the higher accuracy and more balanced macro FI across all emotion classes and the confusion matrix and FAR classes. The confusion matrix and for class F1 show where the model still confuse similar emotion, but overall performance is strong. Finally, I saved the best model, check point along with the tokenizer and any supporting files so it can be reused later without returning.